All right, guys. So good afternoon again to everybody. So we're going to go through Unit 5, and Unit 5 deals with consumer behavior. So what I'm going to do is I'm going to launch the um, PowerPoint with it. You guys seeing this?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. Okay, so um, let's start to look at this. So as the name suggests, consumer behavior has to do with economists' attempts to explain why we as consumers behave we do the way we do. And there are two theories that they're going to be looking at, and that is um, the marginal utility theory and the indifference curves analysis theory. So we'll see how that works out. Now that's why it's called consumer behavior and utility maximization. Now, for those of you who haven't, especially those of you who haven't really done too much economics before, what do you understand by the use of the word utility? This word here.
So I so I would think that utility means how the consumer, whatever the consumer uses.
All right. So utility actually um, is a synonymous in economics with satisfaction. How much utility you get out of a good is measured in terms of how much, or measures, I should say, how much satisfaction you're able to derive from the good. That's why it's consumer behavior and utility maximization. So the word utility is synonymous with the word satisfaction. That makes sense? Now that word is derived from usefulness. So the only way a good is provides us satisfaction is because it's useful. That's why they use the word utility. And thus, the objective of consumers is to maximize the amount of satisfaction they derive from the goods that they purchase. So that's why it's referred to as utility maximization. All right, because that's what you're trying to do as consumers. When you spend money on a good, you want to make sure that the amount of satisfaction that you receive is greater than the amount of satisfaction um, than the amount of money that you're spending. Right. So I think I'm hearing. All right, I thought somebody was coming. Somebody put up a chat. All right, I need somebody to monitor the chat and read back, because when I go into presentation mode, I can't see. So Mr. Singh says it'll be determined by the units of satisfaction, like how much doubles would be needed for a consumer to be satisfied. Yes, that's a perfect example of what we mean by consumer satisfaction. It'd be better if you were able to talk rather than chat. But as I said, can I get somebody whose microphones work to be able to read out the chats, if anything, please?
Sure, no problem, sir.
Much. All right, so let's get started by looking at the theory. So again, with all of the units, I've put into it the course outlines that we're looking at and the information from the course outline into the presentation so you know what we're trying to do. So we're looking at, with this unit, looking at deriving consumer equilibrium using using marginal utility and indifference curves approaches. We said that. Explain the concept of marginalism, utility theory, ordinalness and cardinalness, budget lines. So these are some of the concepts that we're looking at. Derive the demand curve using the marginal utility and indifference curves approach. Apply the theories to the real world by identifying the exceptions to the rule, for example, given goods. Explain price and income consumption line, derive the income and substitution effect of a normal good. And that's primarily what we're going to be looking at, what the course outline asks us to do. So So we're starting again with this concept of utility. Utility is the satisfaction or reward a product yields relative to its alternative, and therefore it becomes the basis of choice. It's one of the reasons why, as Prashant had said before, it's why some people might choose for breakfast to eat a doubles as opposed to some people might want a pie. Because to them, the amount of satisfaction that they derive from one or the other is either going to be greater or smaller depending upon the preference of the individual. Um, the main thing about this, especially under the marginal utility theory, is that it is a very subjective thing because some of you may like doubles, but who here doesn't like doubles? Let's hear. Is there anybody here who doesn't like a good doubles?
Me too.
Yeah?
Me
Why,
too.
why, why don't you like doubles? What doubles are
Because it's basically chana and roti. So.
and what's wrong with chana and roti?
So I guess when you put sweet sauce and shado beni on chana and roti, think like I don't know, so I just not favorable to it.
All right. Well, I don't eat doubles primarily because it's not good for me. It's not good for anybody, right? Um, Especially in excessive quantities. So again, as with anything, anything in moderation. But I guess maybe over the years I've eaten too much doubles, so now doubles doesn't yield for me that much satisfaction. Now I use an example here that when we want to differentiate how much satisfaction we've derived from it, we have a concept called utils. Utils is a unit of satisfaction. So it's a subjective measure of how much utility or utils you've derived from the consumption of a particular good. So for example, a box of KFC might yield to a consumer 50 utils of satisfaction as opposed to doubles providing only 10. That's why if you want to arrive at the same amount of satisfaction as when you eat a box of KFC, you might want to eat up to about what, 5 doubles to get to the equivalent of how you might feel if you bought a box of KFC. You understanding that logic there? Yes?
Yes, sir.
Yeah. Now it's as it says here, the measurement is subjective. But the more important thing is that we want to get from this is that although it's subjective, because somebody, two people might value the same good differently, what we can see is when we look at what people do based upon how they feel about a particular product, that is what we are going to be looking at, not the how much utility that you derive in exact amounts, but when it is greater or smaller, what we are interested in looking at is how you behave. And therefore, understanding these theories that we're looking at here will help us with some degree of prediction. So we can utilize these theories to predict behavior. And that's what the usefulness of these theories are about. So some concepts that we need to understand here. We start with total utility. Total utility will be the total amount of satisfaction obtained from consumption of a good or service. Is that a comment or is somebody trying to get into the class?
So I don't think it's not
No,
a comment.
nobody's trying to come in. Who that is? Who's a Leah Jadunanan?
Shucks, I forget to change the name. That's me. That's Sullivan, sir. I'm gonna change it now.
No, don't bother. I just needed to know who you are.
I didn't realize I did that. Sorry about that, sir.
No, that's probably somebody else Gmail accounts logged in. Um, Those came in. All right. Were you able to? Was anybody able to see her? I guess not. I'll have to look out for those things. All right. So total utility measures the total amount of satisfaction gained from the consumption of goods. So let's say, as we said before, if I get 10 utils from each unit of doubles that I consume, then it's likely when I get to 5, and we have Miss McIntyre. Hello, Miss McIntyre. Welcome. I don't know, where did she go? Here she is. I think slowly. Hi, Miss McIntyre. Are you capable of speaking? All right. Possibly not. Okay, so all right, so total utility would be the absolute amount in total of how much. So if my first well, we'll see an example of this, but total utility just adds up all of the utility that I've experienced as I consume a number of a particular good. So, like I said, if I had 5 doubles, how much utility total would I have gotten? Now, marginal utility measures the additional satisfaction gained by the consumption or use of one more unit of something. So that simply means is how much more satisfaction or less satisfaction did I feel when I increased my consumption by one more unit of the item. And that change is going to be critical and important. And that then brings us into the first law that you're going to look at here, is the law of diminishing marginal utility, which says that the more of any one good consumed in a given period, the less satisfaction or utility generated by consuming each additional marginal unit of the same good. Now, what that simply means is this, and all of us experience this because it's universal. When you're hungry and you eat the first item that you chose to eat at that point, so it might be doubles or it might be pies. The first pie would yield a certain amount of satisfaction that will provide for you some degree of, well, of satisfaction so that your hunger starts to diminish. Now, the second pie or doubles that you then eat after that first one will still probably give you some level of satisfaction, but not as much as that first one. Now, the classic example that's utilized in textbooks would be you go for a walk on a warm day and you come into the house and you start to drink water, glasses of water. The first glass will probably for you provide the greatest amount of satisfaction. And then subsequently, any other glasses of water that you then consume will still possibly give you more satisfaction, but it will not be as great as the first one. So in other words, the law of marginal utility means that as we consume more and more of an item, we get less and less satisfaction. That sounds reasonable. Does that make sense to you?
Yes.
All right. So this is actually the law of diminishing marginal utility is really trying to describe something we already automatically feel, and that law is measurable. Once we could start to ascribe utility values to the amount of goods and services that we consume. So look at this table. Now in this table, we're talking about an individual here called Ollie, and he's consuming crisps. Now this is a UK book, so crisps for our sense is potato chips, okay? So packets of crisps consumed, and they're measuring total utility, that's what TU is in utils, and marginal utility in utils. The number of packets that they're consuming is 6 packets, starting with 0 to 6. And what we're going to do is we're going to go across here and look and see what happens with this sorry, consumer as they continue to consume more and more items. So obviously, when you consume nothing, you get no satisfaction. That's why your total utility is going to be zero, and your marginal utility cannot be measured, because marginal utility is measured utilizing a formula which looks at what was the change in total utility experienced when you consumed one more unit of a particular item. That will be this value here. So when the person, Ollie, consumes the first packet of crisps, he experienced 7 utils of satisfaction from that one unit. So his total utility at that point will be 7. Therefore, the change from what was taking place here is 7 minus what he was experiencing before, which will give us 7. You all understanding that? 7 minus 0 will be 7. Making sense? Yes?
Yes, sir.
Okay. So now, according to the table, he eats a second pack of crisps, and his total utility rises by 11. His marginal utility would measure what was the change in total utility from the first packet. So 11 minus 7 will give us 4. That makes sense?
Yes, sir.
Yeah. Okay. The third pack that he consumes, his total utility rises to 13. And therefore, his marginal utility will be 13 minus 11, which gives us 2. So far, so good? Yeah? So you
Yes,
notice
sir.
something here, that the marginal utility is actually measuring the amount by which his utility is changing as a result of his each consumption of the good. So the fourth packet, he's at 14. The change was positive 1. The fifth packet, it didn't change. It was the same thing as before. So therefore, 14 minus 14 gives us 0. So his marginal utility tops off at this point. And, well, I should say, gets up to 0 at this point. And then he eats another pack. And that means when he gets that pack, and his total utility falls to 13. So 13 minus 14 will give us minus 1. Now, what does that mean? Well, it's like drinking alcohol. Think about it from this perspective. You go to a bar and you're lying somewhere and you take a drink. The first drink probably yields some really good feelings. You start to feel relaxed and comfortable, and that first drink really hit the spot. I don't know if you're into drinking beers or whatever you are drinking, but that one will probably yield the most amount of satisfaction. So you're like at 7 there. But like with most things, we tend to continue doing things. The second drink is good, but it wasn't as good as the first, because the first one really hit the spot. So you would have what is called diminishing marginal utility. But consider what happens when you get to the point when you took a drink and it's like you miss. Nothing happened. That means, between the fourth and the fifth drink, let's say you're drinking beers here instead, there was no change in the amount of satisfaction. And you still insisted in drinking a sixth drink. And that's when you start to get into the negative things. You take that drink and you might throw up. That's when Ralph comes visiting. And that's because you've gone beyond what so your satisfaction starts to get into negative values. That making sense? That's sort of like eating and not if you get that concept. That makes sense to you guys? So the idea is that marginal utility can move into a negative value, because if we continue consuming the product, we can start to experience negative satisfaction, or what economists refer to as dissatisfaction. That means you continue doing something until you start to experience negative returns as opposed to positive responses or positive returns. Now, let's look at the graphing of that information, because this is what we love to do in economics. We like to take those numbers and tables and put them into graphs. Now, let's look at the relationship here. You'll notice that the total utility curve starts from 0 and continues rising right up until it's supposed to be more of a flat line here between the fourth and the fifth. Why? Because both of them were at 14. You've seen that there? All right? But for continuity purposes, they sort of rounded the curve. And then right after the fifth, we started to go down. Now, what happens with the marginal utility curve, which is just measuring the change? It starts at remember there was no utility for when we had no satisfaction. So marginal utility doesn't start from 0. It starts at 7 here, at this point here. You get my laser pointer. All right, it starts at this point here. And then each successive unit, for each successive unit that we consume, our marginal utility continues to fall. It's downward sloping. Making sense so far? So every packet of crisp this person consumes, Ollie that is, that they consume, brings lower and lower levels of satisfaction across the board. Until if he continues to consume up to the sixth item, he would eventually begin to experience negative returns. Notice this is the 0 line here. All right? And that's because in this concept, we can experience negative satisfaction. Everybody's following this so far.
Yes,
All
sir.
right?
Yes, sir.
Now, the marginal utility is actually, well, you see some calculations here that's looking at the slope of the line and that kind of stuff. So don't go panicking about the mathematics for it just yet, all right? So, because what's been measured is change in Q over change in total utility, which is giving us a curvature of 1, all right, a gradient of 1. So the idea is that what we're looking at there is the relationship. So we make a statement now from the law of diminishing returns, and that statement says, so let's look at the conditions here. The marginal utility curve slopes downwards. This is simply illustrating the principle of diminishing marginal utility. The total utility curve starts at the origin. 0 consumption yields 0 utility. That's where it starts from the origin. It reaches a peak when the marginal utility is at 0. So let's understand what it's saying. When the marginal utility is at 0 here, total utility is at its highest point. Now this graph doesn't quite reflect that. It should really, these 2 points represent the highest point that the total utility curve gets to. So that's what I'm saying. Here should be a flat line. So when marginal utility is 0 at 5 packs of crisp, there's no addition to total utility. Total utility must be at the maximum, the peak of the curve. All right, so far so good. Everybody's following up. Marginal utility can then be derived from total utility. The slope of the line joining two adjacent quantities on the curve. For example, the marginal utility of the third pack of crisp is the slope of the line joining points A and B. The slope is given by the line of such a line is given by the formula delta TU over delta OQ is equal to MU. Okay, so let's demystify the equation here for those of you. Delta means change. So change in total utility divided by change in quantities consumed gives us the marginal utility. Now let's go back to the graph. Look at it here. Change in total utility is 2 divided by change in quantity, which is from here to here, it's not actually 2, it's 1. Okay? So that the marginal utility is 2 divided by 1. Seeing that there? I know it says 2. All right? Total utility is 2. Total change in quantity is 1, 2 to 3. So that actually should be 1 here. So the idea that they're looking at here is that in our example, the change in total utility is equal to 2. Total utility has risen from 11 to 13. And the change in Q is 1. 1 more packet of crisp has been consumed. Thus, the marginal utility is going to be equal to 2. Now, this is just the calculations in its full form. If Ollie were to consume more and more crisp, would his total utility fall to 0 and his marginal utility will become negative? Yeah, well, that's supposed to be a question. If let's say if Ollie were to consume more and more crisp, his total utility will fall to zero and his marginal utility will become negative. That's what we would see from the diagram and from the figures. So the point about this is so before I come back to that, let's come back to this. Everybody understands this formula here? Yes?
Yes, sir.
Yes,
All right.
sir.
And they understand how we arrived at that marginal utility. Now, one of the things that we can see from the formula is that the marginal utility curve is downward sloping, meaning that as we consume more and more items, we experience less and less satisfaction. Now, the important element about this thing here is that this is what we know happens. All right. In other words, economists say that when we're consuming goods or services, the first time we consume it is we will be experiencing the greatest amount of satisfaction. Anything after that, we will experience less and less satisfaction. Now, we're not going to say it may not take just 5 packs for us to get to a negative value. All right. But the idea is that we will begin to experience falling levels of satisfaction. Now, because that's happening, it means that if we start to equate money with this, how would we continue to buy? Why would we continue buying a good if its value to us or the satisfaction we're deriving from the good keeps on falling? What that simply means is that for us to continue buying a good or service, we have to make sure that the price that we're paying for that good, and this is going to be explained further, um, we are going to have to be making sure that the price we're paying is less than the satisfaction that we are experiencing. That's the only reason why we continue buying the good. That making sense? If the price starts to exceed the amount of satisfaction that we derive, then we're not going to want to consume that good. Why? Because, why, guys? Why wouldn't we want to consume the good if we're paying more money for it than the price we're actually being paid? Well, let's put it to you this way. Would it make sense? Is it logical for us to continue purchasing a good for which we are experiencing less satisfaction than the price we're paying for it? Is that logical?
No, sir.
Yes,
Right.
sir.
So the idea is that if we are logical consumers, then once we, if the price of a good is higher than the amount of satisfaction we're getting from the good, we will no longer consume it. Now, let's put this in a kind of realistic fashion. I'm sure that there are times that you all went somewhere, bought something to eat, and the minute you bit into it or you tasted it, you realize you wasted your money. Have any of you all experienced that before?
Yes,
Yeah.
sir.
Yes, sir.
Yeah? That means that you will never buy that good again, not so? At least not from that particular vendor or store. Because the product produced by that company or by that firm is not giving you satisfaction beyond the price that you paid for it. That makes sense?
Yeah.
All right. So it's the same thing that we're going to be saying here. For us to continue consuming a good when we have to factor in paying for it, we don't get goods for free, right? We don't get goods for free, do we?
No, sir.
Huh? Do we get goods for free?
No.
Right. So Hold on a second. Let's try to hook in something. All right. So that brings us to this equation here. And that is for every good that we consume. So let's think about when you go to the grocery. How many of you all here do the groceries in your household? Nobody does groceries in the household? Kind of people we have here, right? You're seeing this white screen, right?
Yes, sir.
So what the theory is telling us is this. For every item that we put into our basket, so give me the marginal utility of, let's say you put tuna, right? So over the price of tuna has to be equal to 1. That's the ratio we're trying to get. That's why if you look at anybody's basket or even your own baskets, you're not going to see 1 tin of tuna. You understand? How much tuna do you normally see people putting in baskets when they buy?
The
4.
pasta.
Right? So sometimes it's like 4 divided by the price, 4 tins, right? Right? Divided by the price that they're paying for those per tin of tuna. Somewhere along the line, they're getting a satisfaction rating of 1. So it again, for some households it might be 4, another household it might be 3, or it might be 2, or it might be 6, depending upon the price that the tuna price is. Because if the price starts to change, then the ratio changes. But the idea is that we're trying to get our ratio out to 1. So every item that we're putting in our basket when we're purchasing goods we're going to be looking at the price we pay for it and the quantity of that good that we're putting in. And we're trying to ensure that the ratio is somewhere around here. We will continue purchasing this good as long as we're getting more satisfaction out of it than the price. All right. Once we get to the ratio where it is equal to 1, we will stop consuming. So if we are 1 at 4, then we will stop putting tuna in the box. That's one of the reasons why when you go into the supermarkets, they have them bonded together. So you might have tuna wrapped up in batches of 6 and 4 and 8 and stuff like that. You notice there's always going to be some sort of even number, because for some reason psychologically we tend to equate easier with even numbers than we do with odd numbers. You all realize that? That's why, like, when you pick up a dozen of something, it feels like a complete amount to you, as opposed to if you pick up 11, or you might pick up a pack with 10 in it. You all follow what I'm talking about? All right, so I'll tell you one of the reasons why consumer behavior theory is important. This is related to marketing. Anybody here the principles of marketing yet? No, most of you all are first year students, right? So when you do principles of marketing, what you're going to understand is that what we're trying to do with principles of marketing is predict people's behavior. And the prediction of people's behavior is easier when we're dealing with even numbers of things rather than odd numbers. Odd numbers create discord in people's mind, and that discord makes it difficult for people to find satisfaction or levels of satisfaction. Making sense so far? Now, let's come back to the formula. You'd notice in the equation that we have here, we have the mu of x over the p of x plus the mu of y over the p of y plus the mu of the nth item over the p of the nth item is equal to 1. This is the consumer equilibrium utility theory. The X is tuna. Y is what? Name something else you put in your basket of goods. So you have tuna. You might have cheese as the next item. You might have chicken, but chicken will be the marginal utility per pound. You understand? Over the price per pound. You're following what I'm talking about? So
Yes, sir.
when we go to this situation here, the MU of good X over the price of good X plus the marginal utility of good Y over the price of good Y plus the marginal utility of Z, whatever good Z is, over the price of good Z, the price of good Z, all right, dot, 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 plus the marginal utility of the nth, now it's supposed to be like this, right? Nth item over the price of that nth item. The entire ratio needs to add up to 1. That means that every item that we put into our basket of goods, we are equating the price we've paid for it with the amount of satisfaction that we've derived from each item. That's why I said this here might represent tuna. This here might represent rice. This might represent chicken. All right. Until we get to the last item we put in the basket of goods when we're in the grocery store. Making sense? This is one reason why, guys, they always tell you don't go shopping when you're hungry. You all know about that strategy? Don't go shopping in two things. Don't go shopping while hungry. Have a meal before you go shopping, and don't go shopping when there's a lot of people there, because then you have a tendency to rush your choices, and therefore you'll get this this thing wrong. All right. You're following the understanding. This is consumer equilibrium. Remember, all we're trying to do is to arrive at consumer equilibrium positions where the marginal utility for each item, we are trying to make sure that we've equated the price we paid for the good with the amount of satisfaction we derive from the good. That's why here you might have 4 tins of tuna, you might have 9 kgs of rice, all right? You might have, this might be about 10 pounds of chicken, all right? What else? Give me some other items you all will be putting into your, what's on your grocery list? You have sugar,
Ice cream.
that ice cream. Who's the ice cream?
Brittany, sir.
All right, so Brittany, what type of ice cream would you buy?
So ice cream is ice cream.
No, it's not.
I would buy probably the strawberry. The
Not the flavor, I'm talking about the brand.
I forgot the name.
Yeah,
The one with the red buckets.
is that
Creamery.
no, the one
Creamery, yes.
called creamery. All right. So my mom likes this, but I prefer Haagen-Dazs. So when I go to the grocery, I buy Haagen-Dazs. When she goes, she buys creamery. So we usually have both brands in the house for whatever reason. Now the point I'm trying to make now is that the brand now becomes important because okay, how many households here consume tuna? What brand of tuna do you consume?
Brunswick.
Brunswick.
Right. All right. So Brunswick. Who? Anybody else? What about Mayflower?
I don't know that brand, sir.
Do you know that brand? Anybody knows any other brand? You have the Nisa. You don't know that brand? Everybody running on Brunswick, right?
Yes, sir.
All right. All right. So what are some other things? What about potatoes? Do you all put potatoes? What about
Yes,
salt?
sir.
Yes, sir.
You all put salt in your basket?
Yes, sir.
Yes.
All right. So who recently did groceries in the household?
Me.
Right. I want you to do yourself a favor. Go through the list of things that if you have your receipt, it'll be good. And observe how much you paid for each item and the total you paid for all of the items that make it up. All right? Because the reason I'm trying to say to you is the amount of each item that you placed in your basket. Now, why would a household buy a 9 kilogram pack of rice?
Because it's a big household, sir.
Well, not only that, but rice is something that we tend to always buy in bulk because rice is something that we can mix with a lot of the other ingredients in our grocery list to make meals, not so? So it has larger amount of greater number of uses. You can boil, well, we always boil in rice, right? But then you could make all different styles of rice, not so? Same thing about chicken. Chicken is something that is easily manufactured or made into different types of goods. That makes sense? And or different types of products. So you could curry chicken, stew chicken, baked chicken, fried chicken, raw chicken, well, barbecue or grill. So because of the variations of uses, it's one of the reasons why we may value it more and get more satisfaction out of it because of the variations of uses that the product has. You all understand? Tuna. How many different things can you make with tuna really?
Just
Well, what's the thing that we make the most of?
Tuna salad.
Tuna
sugar.
paste. What? Hearing some weird things there. What do you all use tuna for?
Tuna paste for sandwiches.
Tuna paste for sandwiches. You know, it's another item that comes is similar to tuna that people
Sardine.
cheese.
What?
Cheese. How much things do you use cheese for? Cheese is
Cheese
also
paste.
right, but cheese paste, or you could just have chunks of cheese. You could toast cheese on bread and then you get a melted cheese. But cheese is also an ingredient that goes into like, have you ever had Parmesan style cheese chicken? Or
Yeah.
rice with cheese in it? Or even a tuna melt with cheese on top? You follow what I'm talking about? Different products have usefulness across a number of different areas, and therefore it increases the level of satisfaction. Now, again, remember the measurement of utility in this fashion tends to be subjective. In fact, all utility is subjective, and that results in us actually ending up in a situation where a lot of these things are quite what's the word I want to use? They are um, subjective in nature. All right. So that's why when we use this formula here, this formula already is telling us that every item that we're putting into our basket, we're trying to get this equation down to 1. So for every item, we're equating the quantity of the good with the price, the satisfaction we get from it, with the prices that we paid for it, and we're trying to get it down to 1. You're following this concept?
Yes, sir.
Yes, sir.
Okay. Now the main thing that we want to do is we want to be able to take the margin utility curve and derive from it our demand curve. All right. So if the price of the good were P1, the person would consume Q1, where the marginal utility is equal to P. Let's follow what's going on here. Now on this side here, we have our, on this side here, this turn on the, so this side here we have our utility curve. This is downward sloping. And on this side here, we've equated our utility curve with our demand curve, put in prices and quantities here. All right. So we know that when we first start consuming the good, our utility is at its greatest, and then it will continue to fall. And if you continue consuming, it'll eventually get negative, equal to zero. Correct? Remember that from this diagram here before, right? From this diagram here, we know our marginal utility curve will fall, get to zero, and continue falling downwards. Now we don't allow that to happen because we would stop consuming the good before then, correct? So this here is now telling us how is marginal utility used for us to derive a demand curve. So this is what happens here. So at P1, the price is high. So therefore, when it comes across to our utility curve, this is the amount of utility we get. We'll only consume Q1 quantity of the good. At a lower price, we will want to buy more. Why? Because although our utility is much lower, what we're going to be able to do is it gives us the opportunity to consume more. So if the price of the good were P1, the person will consume Q1, where the marginal utility is equal to P. Thus, at point A, point A would be 1 point on that person's demand curve. See that there? This point A here. If the price fell to P2, consumption will rise to Q2, since this is where the marginal utility is equal to Q2, P2, sorry. When we come across here, B is the point where we are equal to P2. At the lower price, we'll buy more of the good because the price equates with a lower level of satisfaction. All right. Likewise, if the price fell to P3, Q3 will be consumed. The point C is the third point. When we connect these points together, we will get a demand curve, and we will be able to project it as a straight line if you want. All right, to be able to get that relationship between prices for the good and the quantities that we're willing to buy based upon the utility that we're deriving from it. And remember we said, for us to buy more of a good, the price of the good has to fall. Because we know as we consume more, our utility is falling. Thus, the falling demand, the falling marginal utility curve is the same shape like the demand curve. So the demand curve falls from left to right, it's downward sloping from left to right. So therefore, it reflects the same relationship we have with the amount of satisfaction that we have when we consume more and more of an item. So the marginal utility curve is downward sloping from left to right, reflective of that relationship, where as we consume more and more of an item, we derive less and less satisfaction. Correct? We good there? Hello.
Yes, sir.
All right. Anybody monitoring the chat to make sure there's no questions coming up there?
Yes, sir.
There are no questions, right?
No,
Right.
sir.
So what we have here is individual people's demand curves for any good will be the same as their marginal utility curve for that good, where utility is measured in money. That was what we were looking at before. Thus, as long as an individual is seeking to maximize consumer surplus, hence consume where P is equal to marginal utility, price is equal to marginal utility, their demand curve will be along the same line as their marginal utility curve. That's the point that they're trying to make here. That this marginal utility line here will be the same point of their demand curve. That's why the marginal utility will be equal to the demand curve. So this is the reasoning behind it. All right? Because in order for us to continue consuming the good, because we know our satisfaction is falling for every successive unit that we consume, the price of it must be falling. So far, so good. And of course, if the price is very low, it allows us to buy more of the good. So therefore, when prices are low, we will buy more. But when prices are high, we will buy less because the satisfaction that we deriving, there's less satisfaction that we're going to be getting from it. Well, no, we will get greater satisfaction, but it means for us to buy more, the price must come down. So high price goods we buy little of, low price goods we buy lots of. So that's the relationship that we're seeing there. That sounds logical to you guys? Yes?
Yes, sir.
Let me hear one voice in particular.
That's Brittany, sir.
Yeah, Brittany. All right, so that means, in essence, therefore, that the marginal utility concept is what we utilize to derive this demand curve that we talk about. Now, we're going to go into demand in more details in the next unit, but we're trying to get the background to it. So that brings us now to the second analysis system that we're utilizing, and that's indifference curves analysis. So let's start looking at this. What is an indifference curve? An indifference curve shows all the various combinations of any two goods that give an equal amount of satisfaction or utility to a consumer. So we come back to the same concept of utility. But in this case here, an indifference curve is going to put together a combination of two goods that will yield similar levels of satisfaction to a consumer. Now, let's go back a little bit and look at the word utility. Not utility. This word here, indifference. What does this word here mean? If we use the word indifferent, if I said that I am indifferent towards you, what does that mean? Anybody? All right, so let me put it to you from your perspective. If you said you were indifferent towards whether you did economics or management, what does that mean? Nobody knows. I actually have to check and see if anybody
So a
cares.
different attitude.
What? Sorry, what's that? Indifferent attitude?
So does it mean not showing an interest?
Showing. Say that again. Sorry.
Not showing an interest.
Not showing an. Well, actually, it's a little thing. It means I don't really care. If I do one or the other, it doesn't really matter. I'm indifferent as to which one I want.
Combination.
No, it's not a combination. It's an attitude, a feeling. Now, it sounds weird, but indifferent speaks to a feeling. If somebody is indifferent towards you, it means they really don't care one way or the other how you feel. Do you understand that?
Yes, sir.
If somebody is indifferent towards something, it means that they don't really care about it. They have no preference, therefore, whether they have it or not. That is a little clearer there. It's important we understand that, because that concept of indifference is going to be important for us to understand where this particular concept is going to go. All right. So let's look at it here in more details now. So we said an indifference curve shows all the various combinations of two goods that give an equal amount of satisfaction or utility to a consumer. The indifference curve, a curve showing all those consumers, combination of two goods between which a consumer is indifferent, i.e., those combinations that give the same level of utility. So the idea is that each combination of goods that we're going to be looking at in the diagrams here, so this is an indifference curve here. It doesn't matter which combination I get I don't care because they all yield the same level of satisfaction. All right. So that means having 30 pears and 6 oranges for this consumer is the same as if they had 10 pears and 13 oranges. Now, this is individual. So it means that this is for this individual, whichever individual this is. Let's say this is Ollie's indifference curve between pears and oranges. Now, for somebody in the Caribbean, where pears are more expensive than oranges, and sometimes we can just get oranges in the back of the yard, our indifference curve might be different. Why would I say that?
Because we will be having more oranges than apple
Well, pears. We'll talk
and
about
pears.
Yeah. And
Because
it's because oranges are more plentiful in our area, and we
yeah,
are likely to be able to
yes.
access more of it. That's correct. And the more of something that we have available, or the more we've consumed, then we are going to value that less than something we don't get a lot of, correct? How many of you all like those big um, purple plums that they sell in the markets that we get imported? Or how many of you all are familiar with Governor Plum?
Yes, sir.
All right. Do you get a lot of it?
Not
No.
this time.
Exactly. So that in relation to plums in general, the green ones as opposed to the purple ones.
Right. Well, that is more accessible in our country than the foreign plum.
Right. And therefore it means that we might value that which we don't get often more
Exactly.
than what
Or
and
that's
this,
stuff
right.
that
So,
our taste
right.
for it, or it will be less, as explained before, is that we get so used to it that is not really giving you that much satisfaction as before.
Right. So good. We're on the right path here now. Because in this combination of goods here, we have pears and oranges. And what I'm saying is, for somebody who lives in the Caribbean where we get oranges a lot as a tropical product, then we might not value oranges as much as we value pears because oranges are so readily available. You understand what I'm saying? So that we might give more value to the pears because they are more difficult to come by. And therefore, because we demand it, we will put more value to it. We'll be willing to pay greater prices for it. That makes sense? All right, so let's leave this alone, leave that concept alone. But look at what this indifference curve is saying. It's saying that either of these combinations here, from A to G, ref, uh, provide for us combinations of these two goods, pears and oranges, to which this consumer is indifferent as to which one they get, as long as they get one. They don't care. They will take point G, which is probably, well, let's take those. Point F, which is 8 pears and 15 oranges, or point A, 30 pears and 6 oranges. They don't care as long as they get one, which means they are indifferent to whichever group that, whichever combination they get. So the curve above shows various combination of pears and oranges that yield this individual the same level of satisfaction. Because to me it's all the same, then I really don't care which one I get as long as I get one. It will yield to me, and this level of satisfaction has not been measured here. This might be 20 utils of satisfaction. That making sense so far?
Yes, sir.
All right, now, so what are the features of these indifference curves? First off, indifference curves are downward sloping from left to right. Okay? This represents the rate at which the individual is willing to substitute one good for the other. The slope of the curve represents the marginal rate of substitution. All right, so let's go back to the curve and look at that. We're saying the downward slope of this curve represents, downward sloping from left to right, It represents the marginal rate of substitution. What is the marginal rate of substitution? It is the amount of one good I'm willing to give up for the other. So it's the amount of pears, the rate at which I am going to give up pears for oranges as I come down the curve. Is the rate constant? As far as you can see, is the rate of substitution constant? Or is it changing as we move along the curve?
Changing?
Yes, it's changing. If it was constant, then it'll be what?
A straight line graph.
Be a straight line graph, correct. Right. So we know therefore that as we move down the curve from left to right and right to left, that the rate of substitution is changing. You'll also notice something very important. For me to move from A to C, or well, let's say A to B, I'm willing to give up how much? 6 units of pears to get 1 orange. Why am I doing that? Why would I do something like that?
To give up 6 pears in exchange for 1 orange?
Yeah, why would I do that?
Is it because...
Okay, you just disappeared there. Is it because... Okay, somebody else needs to pick up. I think she's on the right track. You seem to have lost her. Hello? Hello?
Hello?
Hi, you're back?
Yeah, I was saying that with the pears, right? Is it because they're accustomed having that many amount of pears and that they only just have the orange, which is
All
left?
right. So let's go to
Yes,
it has, right. It has a lot to do with that. If we look at the position A, how much pairs do I have? We have 30 pairs, correct?
Yes.
But we have 6 oranges. What do I have more of? What do I have less of?
More pears and less oranges.
Right? So what will I get fed up of very quick?
The pears?
Correct. So therefore, to get 1 unit of oranges, because now that is the one that I have less of, I am quite willing to give up 6 pairs to get 1 orange. Why? Because when I have a lot of one thing, it becomes less valuable than if I only have a few of those items. Does that make sense to you guys?
Yes, sir.
And that's behavior. Those things that we have a lot of, we tend to be a little more careless with it. We're willing to give it up and we're willing to get rid of it and that kind of stuff. But in relation to something we have a little of, those things become precious. That makes sense? Now go to the other end of the curve and you'd realize that, so that 6 to 1 represents 1 rate of substitution. But let's go down to the other end now from let's start at point F. I now have 15 oranges and only 8 pairs. So I have more oranges now, right? And I'm willing to give up from 15 to 13. I'm willing to give up, that's what, 2 oranges to get 8 to 10, 2 pairs. So the rate of substitution there is almost 1 to 1, yeah? Making sense?
Yes,
So
sir.
look at the gap from G to F. At G I had 20 oranges, all right? And I probably only had about maybe 6 pairs. But I'm willing to give up from 20 to 15 oranges to get a small increase in the amount of pairs. Why? Because I have a lot of oranges and less pairs. So therefore, the pairs become more valuable in the exchange process that we're going through there. That makes sense?
Yes, sir.
So what I have a little of, it becomes more precious and therefore more expensive. And what I have a lot of, it means I am quite willing to give up more of that item. So that means the marginal rate of substitution changes as we move along the curve from left to right in relation to the relative rate at which I'm willing to substitute one good for the other. That's what this downward slope represents. This represents the rate at which the individual is willing to substitute one good for the other. Thus, the slope of the curve represents the marginal rate of substitution. It is convex to the origin, and the curve approaches both axes but never touches. Those are two more features, thus indicating that there exists a diminishing marginal rate of substitution, meaning that, going back again, as we get to a point where I have less of one item, I am willing to give up less of that item to get more of the other. Notice too, the curves never go to the x-axis. Look at this here. The more a person consumes of good X and the less of good Y, the less additional Y will that person be prepared to give up in order to obtain an extra unit of X. That is, delta Y, change in X, change in Y, change in X diminishes. Thus, the fewer of one good that you have, the greater you value it. Thus, you are less inclined to exchange it cheaply, and you will always ensure that you have some of both goods. Thus, the curves never touch the axis, meaning that the quantity of any one of the goods will never fall to zero. So if we go back to that diagram, you realize that the curves approach the axes, x and y axis, but they don't touch. And that's another feature of indifference curves. It means that you will always make sure you at least have one of the goods. You're never going to give up all of the good, at least from this particular situation here, because you're always going to want to make sure you have both of the goods. You want apples, in this case here, oranges and pears. So far so good. You all understand these features?
Yes, sir.
Yes, sir.
All right. Any questions about this? So the slope of that downward curve represents the what? The slope of that indifference curve represents the
Marginal rate of substitution.
marginal rate of substitution. Yes. All right. Very good. Let's remember that, because that's a critical feature. Let's look at another feature here. There exists an infinite number of indifference curves, and this can be seen with or what is called an indifference curve map. So now we have, moving outwards from the origin, an infinite number, and in between each one of these, we could put another one. You believe that? What is that representative of, you think? In between each of these, we could actually put another, we could put another indifference curve. If I could ever draw this in the correct way. All right. Why could we put another one? What would that represent? Well, it's right here. The answer is right here, you know.
Unlimited one.
Sorry, because we have unlimited ones. Yes, that is correct. Because we have unlimited ones, we can always, we will always find, and what will also happen is that we can continue having more and more. Why? Why can we continue having more and more indifference curves going outwards like that? So we could have I6 and I7, and could have another one up here, I8 and 9 and 10, and in between 6 and 7 we could have 6.1 and 6.2 and 6.3, all that kind of stuff. Why is that?
So for customer satisfaction.
Because we have unlimited wants, and we will always want more. That, remember at the very beginning of the course, it talked about unlimited wants. That's
Yes.
one of the economic problems. So then the understanding is that because there's unlimited wants, it means that we will always want more and more. That's the nature of humans. Now notice, on this diagram here, they didn't say what good X and good Y were, but they were just using this as a thing. So we understand that there's an indifference curve map that exists as well. So that there's an infinite number of these indifference curves going forward and backward, because even after I1, there's one behind here that would exist as well. All right, but they will hold to the same condition as that they would not touch the x-axis or the y-axis, but they will float above it. All right, let's go to another feature. Each indifference curve represents greater levels of satisfaction as we move outward from the origin. Thus, I1 represents a lower level of satisfaction than I2, 3, and 4, and 5 represents. I5 representing the highest level of satisfaction on this indifference curve map. Notice also that the bundles of both goods are increasing as we move outwards. So yes, we can have, let me just show you something here. We can have a point here, and we have a straight line coming across. Now, if that was straight, means we have a constant value of good y. So let's call this y1. But the combination is going to be such that the amount of the other good is increasing while the other good is remaining constant for us to be able to move across all of these. So it means that the combination, while one unit is constant, the other unit has to be increasing to be able to, for us to move from one to the next. Okay. Similarly, we could also draw a straight line from the x-axis where the amount of x is constant and come up. Oh God. You notice that x, if this were a straight line, would be these items here, but you notice that the quantities of y with x being fixed has to be growing by more and more units to be able to get to higher levels of satisfaction along these indifference curves along this map. All right. So what is the objective of the consumer, do you think? If the consumer wants to maximize satisfaction, what must the consumer do? Just out of logic, where would you want to be as a consumer? Would you want to be down here, or would you want to be up here? Which indifference curve would you want to be on?
So I think you would want to be I5.
All right. Okay, so you have your microphone and your speaker on your computer. So you want to mute off one side if you're using your phone for audio. Okay. Yes, and Richard is correct. To maximize satisfaction means that you want the most amount of satisfaction possible. So you'd want to be somewhere along I5. So I5 is the objective. And if there were indifference curves outside of I5, that's where you'd want to be. You'd want to be at the highest possible indifference curve that you can get to. That makes sense? Yes?
Yes,
All right. So this is another feature of indifference curves. Indifference curves cannot intersect. Now, logic should tell you why, but let's see if we understand this point that it's trying to make. The point A at the intersection of IC1 and IC2, see that point here? This point A here. This is shaded over in red. This point here means that that bundle of goods represents two different levels of satisfaction simultaneously to this individual, which is simply not a rational idea. Now, so in other words, it means that if this is a combination here that represents one bundle of goods, and to this consumer it represents two separate levels of satisfaction simultaneously, level 1 and level 2 at the same time, then that cannot possibly exist. The only way that could possibly exist is if the person is suffering from some kind of psychosis, multiple personalities simultaneously. And that would no longer hold to the concept of being rational. So remember, the concepts in economics are based upon the understanding of rationality. So this is not rational. That's why indifference curves cannot intersect, because one bundle of good cannot represent to the one individual two separate levels of satisfaction. That's not logical. And therefore, that is why indifference curves do not intersect. So when you're drawing your indifference curves, you can't allow them to intersect with each other. So far, so good. Everybody understands why they can't intersect?
So I could just say it one more time.
Take it one. All right. So let me ask you a question. Do you eat chicken and chips?
Yes.
All right. What's your favorite meal to order?
That is all. Probably a fry and a snack box or something because I don't really eat much of the cakes. Probably just a one-sided chicken with fries.
All right. So a one piece with fries, right?
Yeah.
Okay. So that will yield for you a particular level of satisfaction, right?
Yeah.
A one piece of fries. All right. So if you tell me that a two-piece and fries and a one-piece and fries is the same thing for you, then I tell you you're cracker as hell. You understand what I'm saying there?
Pardon me?
If you say to me that that one piece and fries is the same as a two-piece with fries, then you're not being logical. Is that correct?
Well, it depends. The one piece and fries that satisfied me. So I would say it depends on the person. Some people
No, no. And again, this is where you have to stop. This is your indifference curves. Nobody else's. It's,
okay.
it's not dependent on other people. This is what this person is saying. They're saying that this combination of the two goods here, and you're saying for if this is your goods, right? This is what if this sounds like, it sounds like a kid's pack,
Yeah.
right? So
Yes,
this kids pack yields for you two separate levels of satisfaction or one level of satisfaction. It has to be one,
yes, it will be one.
right? So that's the point I'm trying to make. It cannot be on it can't represent two separate levels of satisfaction, because this is saying this is 20 utils of satisfaction and this is 30 utils of satisfaction. It cannot be that the same kids pack is giving you two levels of satisfaction at the same time. That's what this law or this rule is talking about. The
Okay.
goods cannot intersect because the one bundle of goods, in your case here, the kids pack of fried chicken and chips, cannot represent two separate levels of satisfaction. That makes sense? No?
Yes, yes, I understand.
All right. Everybody else following that?
So,
Yeah.
question. How about indecisiveness?
Indecisiveness. So give me an example of your indecisiveness.
Um, okay, so I'll use the same example, but you would buy the one piece, right? But considering for later on, you would also, and you're not sure of how you would feel, and if you would be completely satisfied with that one piece, you would buy the two piece as well.
So
I,
you're gonna buy three pieces of chicken and two fries?
I assume so, sir.
But that's even worse. What you're trying to say is that you don't know how much satisfaction you're gonna get from a two piece with fries and a one piece with fries.
Yes, sir.
Do you think that's a rational thinking process?
To be fair, no.
Exactly. What's the assumption that we're talking about here? We're not dealing with mad people. We're dealing with
Fair enough, sir.
so the idea is not at point of purchase there, but point of consumption. Make it, you
Oh,
understand?
okay. Okay, sir, I understand. Okay.
Consumption. The I understand what you're talking about in that you are uncertain of what you think will satisfy you. But when you make a choice, when you consume it, you can't tell me that the one piece and fries gave you the same amount of satisfaction like if you ate a two piece and fries. That making sense? It makes sense now?
Yeah. Yeah. Yes,
What's
sir.
the
Point of consumption, not at point of purchase.
Sir,
Yeah.
I have a question. Good afternoon, everyone. Now I don't know if it is this happen with other females, but with me, like for instance, I am very indecisive when it comes to food. So when it comes to something like probably a two-piece of well a super deal from KFC and pizza or pasta, I wouldn't really know which one to choose, but yet still I will get the same amount of satisfaction if it is I eat any out of the three. So on the curve, how that will be related?
Well, all right. So let me go to a spread. Hold on. So here we're talking about. So what we have in this case here is we have an x and y axis, right? So what are the products that we're talking about? So we have, you said you just a minute, you have chicken
Yeah, probably put chicken and pizza. Yeah,
and pizza.
yeah.
Okay. Um, so you're saying is that when you go to the store, is it that KFC offers pizza now? That's what you're trying to say?
No. I just saying, probably let's say it's in a mall or something, so they close by.
Okay. Yeah,
I
food
just say,
court. So
mm,
so is it that you're gonna be consuming either or you're consuming a combination of?
I mean, it could happen either way, but yeah.
So, so this is what we have to work out here. For this, your concept to be plotted onto this, it has to be that you are consuming this plus this, chicken and pizza.
Okay.
Because then it can't work on an indifference curve if we have, let's say this is pizza here and this is chicken here.
Mm,
All right. So
mm.
it has to be a combination of the two products that is giving you some level of satisfaction. And what
Okay,
we,
so if it is so if it is you're having one slice of pizza and one piece of chicken.
well then that might be down here. So you might here might represent the one what you said one slice of pizza
Yeah,
and
and one
one.
piece of chicken.
Okay, so well that can't be because that's like this here. So you have one. Let's say this is one piece of chicken, one slice of thing, and one piece of that'll be this point here. So that's a lower indifference curve down somewhere down here.
Okay.
Where you had that thing there. But I mean, can you act? And then well, there's an error here because I shouldn't be touching the um shouldn't be touching the.
access?
All right, that make better sense there. So this will be your situation there. Now, I think what you're having a problem there with is again is the same thing. It is a decision that you need to make between two alternatives that you're confusing between a bundle of options. So when we go to a store, it's not that we can buy chicken and pizza. It's a matter of, well, am I feeling for chicken or am I feeling for pizza? Is that is more the case, not so?
Yeah, but
Right. And the
if
you
you know
know
which one to choose.
the option is going to be generally is going to be, should I have a pizza with chicken on it? Because now we have barbecue chicken on pizza and stuff like that, not so? That's something I think most
Yeah, it does.
yeah.
I was just trying to
All right.
put
So
the curve, the difference curve that you were showing just now there in a situation where it may be impossible to say, well, I don't know.
um, I don't think you need to worry about that, the way you're talking about that. Because before we can move from you having this choice here, we have we have to get to the point where we are making that decision. We have to make a decision. So, like for instance, one of the things I do when I'm doing this example is on one axis and the other axis, I actually put two different products which make better sense. So, like on this axis here, I'll put chicken, and on this axis here, I'll put fries. All right, because in essence, when you go to a fast food joint, it's going to be various combinations of chicken and fries that would yield a meal, not so? Making sense?
Yeah, yeah.
All right. So this might down here might represent the one piece. If we look at the amount, this might be the two piece. This might be a three piece, and this might be a five piece. All right. That makes sense? And what happens is this is five pieces, but it comes with, let's say this is one fry. The three piece comes with two fries. The two piece here comes with three fries. And the one piece comes here with four fries. Why? Because we're trying to build a meal that would yield for us 20 utils of satisfaction. And that's what you're looking at, is how much of both products would I need to give me 20 utils of satisfaction. So a one piece with more fries, a two piece with three fries, a three piece with two fries, or a five piece. Why? Because as I increase more chicken, as I get more chicken, I'm willing to have less fries because it's still yielding for me the same level of satisfaction. Now, if you ever, really pay attention to when you go into the to those stores, you should see the same combination impact taking place in terms of helping you make a choice. Because when you go in, you have the option of a one piece, a two piece. Is there a three piece? I know there's a wing special that has something. Then yes, there used to be a three piece called a dinner special, right?
Yes, sir.
Right. That's so the three piece was a dinner special with one fry and a drink. But notice that what they did is that they started to include more items into making up a meal. So that what they're doing is they're playing upon your indifference between different things. Because most people, when they buy a meal, they buy food and a drink, correct? So what they did was pull these items together to set up something to program us into making that choice. But in making that choice, what they also did is they locked us in to a particular selection of the types of cuts of chicken. And that is where they make money on us, because the more fleshier meat would cost more, and the bonier meat costs less, technically speaking. And what you find happening is that a lot of people Trinidadians like to chew bones, right? Would you agree with that? How many of you all are bone chewers?
Me too.
Yes, they like to bite it up and the poor dog kind of piece of bone to eat. So the point that I'm trying to make here is that the firms have pulled together different combinations which they think you are going to be indifferent to. And that might actually be attached to, let's say right now it might be $25 for that pack, for these variations that you have here. So you'd see around the price level, you may see different combinations that are made up of a number of different items that they're hoping would yield levels of satisfaction for you. That makes sense? Okay. You're following the concept that they're trying to use on you, right?
Yes, sir.
All right. So, but these are the rules that they're kind of following here a little bit. All right. So we're coming back to this concept here. We understand why this one point here cannot be, can't have more than one value, level of satisfaction. So therefore, indifference curves cannot, um, they cannot intersect with each other. That's one of the rules that we're talking about there now. All right. So this is another one here. Indifference curves do not have to be parallel to each other. Now, in the diagrams that we looked at before, we saw that they were kind of, these all look kind of parallel to each other. All right. Over here, the same thing. But the reality is that they don't have to be parallel to each other. The reason for that is because if they were parallel to each other, it would imply that the goods were perfectly substitutable for each other. Now, think about what I just drew there. On one axis, I have chicken. On the other axis, I have fries. Are fries and chicken substitutes for each other? Can they perfectly substitute for each other? Nope. Yes, they both fall into the category of food, but they can't be perfect substitutes. One is a starch and another is a protein. Correct? Let's start with that. And therefore, even if you had closer items, like let's say you were choosing between, like if you went to a restaurant and you were choosing between chicken and pork, they are not perfectly substitutable for each other. So that's why the diagrams that we're going to look at will put them in parallel structures because of the ease of construction. But they do not have to be parallel to each other because it means that the goods are not perfectly substitutable. They can actually be closer, like what you see here at one end and higher on another end. So they don't have to be perfectly parallel to each other, but they can't intersect. Our examples here, pears and oranges are not perfectly substitutable because pears are what? What's the difference between a pear and can we get vitamin C from pears? Citric acid from pears? Nope. Those could only come from citrus fruits. Making sense so far?
Yes, sir.
Cool. All right. So the objective of the individual is, as we said before, to achieve the greatest level of satisfaction possible. And that therefore is going to be somewhere along this highest level of satisfaction here. So far, so good?
Yes, sir.
All right. So what limits us from getting to the highest level of satisfaction? Well, the answer is right here. The amount of money you have and the prices of the goods. That making sense? So now we have to get into another thing. So automatically, this model is a little more complicated because it's allowing us to factor into this not only our preferences for the goods as seen through our indifference curves, but two other features here now of income and prices. So let's look and see what happens. That gives us the budget line, right? A budget line is a graph showing all the possible combinations of two goods that can be purchased at given prices and for a given income. So that means we have to make some assumptions. So the budget line is constructed using the assumption of a fixed level of income. And here we're using $30 and known prices for both goods, where the good PY, whatever good Y is $1 per unit, and good X is $2 per unit. So how do we construct this diagram? All right, well, let's see what it says here. All right, so let me show you how to construct this diagram. So how do you construct now? Notice it's a budget line, right? So it's a linear representation of something. What do you need to be able to construct a straight line? Anybody? Isn't anybody doing Math 119? So what do you need to draw to construct a straight line? You needed to have at least 2 coordinates, right? So think about this. If you know what your income level is and you know the prices of each good, then we could construct this line by making one value equal to 0 and solve for the other thing. So the best way to do this is this. If I spend all my money income on good Y, how much Y can I buy? If I spend all my money on good Y and none on good X, well, at a dollar for one, it means I can buy, look at over here, 30 units of good Y. That gives me 1 point. And then I flip it over and I say, okay, if I spend all of my money on good X and none on good Y, then at $2 per unit of good Y, 2 into the fixed income that I have is going to be 15. And that's what this level is here. This is 15 here, not so? Yes? So once I have this point here and I have this point up here, then I could automatically join these points and I then have a straight line that represents my budget line. Now I can check on B here. B says I could buy at point B. I'm purchasing 20 units of Y and looks like about 5 units of X. Is that correct? So would I use all my money? 20 units there would be $20 spent there on good Y, and that leaves me $10 over, which at $2 I can buy 5 units of good X. That makes sense? Yes?
Yes, sir.
And let's look at point C here. If I'm at point C, I'm buying 10 units of good X, which is $20, and I'm buying 10 units of good Y, which is $10, which means I'm spending my $30 again. So it means that I can buy any items, any combination along this line, and of course I can afford any combination behind this line here. Can I afford this point out here? Let's say this point is, let me bring this out parallel to B and then down to here. So this represents roughly 20 units of Y and 8 units of X. Can I afford that?
No, sir.
Can I? Yeah. How much?
Yes.
Yes?
No, sir, you wouldn't have enough money.
Right. So it means that any point beyond the line here is what we call unattainable.
Okay then.
How are you going to afford it? I don't know who's talking. Eh?
This is Dale. I was looking at just that when you go up that gate there, you know, just like 20 and to just further up, I was looking at it that you can afford it, but after you explain that once you go out of the line,
Yeah.
that you will not be able to afford it.
Right. So if we pay attention to this, this region here is the region that my budget allows me to access. Because at this point here, I'm buying 20 units of good Y and 8 units of good X. I can't afford the good X, the thing, because that is going to be, that's $16 I'll be spending on good X, and I have to spend $20 on good Y, which means that I would have to spend $36. My income is only 30. So therefore, if I try to go here, I will end up in debt of $6 because all I have is $30. So therefore, I'm going to end up owing $6. That makes sense?
Yes.
All right. So we're not working in a world of credit here. So I have to work within the context of what I can afford. So I can only afford the area from here to this point up here, 30, to this point down here, at 5. That makes sense? So this triangle represents, this white triangle here represents my budget constraint. It represents the area in which I can afford to work. I cannot go outside. That makes sense? All right, so let's go across here. In figure 4.8, if you are limited to a budget of $30, you can consume any combination of X and Y along the line or inside of it. That's what we talked about. You cannot, however, afford to buy combinations that lie outside of it, i.e., in the darker shaded region. That's this area up here. All right. This area is known as the unattainable region. This is this part here. Can't afford anything in this region outside of this white area here. All right. To construct a budget line, you require two coordinates. Using the information of income and price, calculate the 2 points A, the point where all income is spent on good Y and none on good X, and then point D, where all income is spent on good X and none on good Y. Now, you all remember how you do this when we still be solving for equations, and we have to plot a line on a graph, and all you need to, the easiest way to do it is make one of the variables equal to 0. That's what we're doing here. By making one of the variables equal to 0, we could solve for the other one. So when X is equal to 0, what's Y? And when Y is equal to 0, what's X? That's all we're doing in terms of this formula here. And that allows us to plot the point A and point B and connect them, and we get our budget line. Thus, the given price and incomes you can plot. Thus, at the given price and income, you can then plot the 2 points, connect them, and construct the straight line that represents your budgetary constraints. So this is just a slide explaining how to go about doing the construction. The slope of the budget line. So this is where we have to start to pay attention now to what the budget line represents. So the slope of the budget line represents the ratio of prices of one good for the other. If one of the prices change, the slope will change. However, if income changes, the budget line will shift, but its slope will stay the same. For the purpose of this analysis, changes will be limited to one at a time. So we're only going to change one thing at a time. We're not going to change price and income. We'll either change prices or we'll change incomes. We won't change one at a time. Why is that? Now, I didn't cover this with you guys, but why are we changing one thing at a time? What does that say?
Scientific method.
Right. So when you all did hypothesis testing, did they go changing everything all over the place? No. Scientific methodology requires that we control our changes so that we can monitor what happens when we control one variable. That's the scientific way of doing things, changing things one at a time and see what happens. That's the kind of diagnostic scientific testing methodology that we utilize in economics that mirrors the scientific approach that's utilized in hard sciences. Making sense? That's why we're only going to be changing one thing at a time, not two things simultaneously. All right, so let's look at this. Let's look at the first change here. When the price of a good fell, good X fell from $2 to $1 with income remaining at 30, what happens to the budget line? The budget line pivots outwards to the right, changing its slope as the quantity that can now be purchased moved from 15x to 30x. Note that the slope of the budget line has changed because the ratio of prices has changed. Note if prices rise, the budget line would pivot inwards. So let's look at this here. So we have a situation where this is the price of Y didn't change, okay, because Y still remains at $1 per unit. So we are at this point here. So what happens is we said we're changing the price of X from $1 per unit to $2 from $2 to $1. Now at $2, remember the budget line was going from 30Y down to 15X. This is the 15X down here. You all remember that? So that this point here was our original position. But when the price of good X went down to $1, the budget line pivots outwards because now we can afford 30 units of X and 30 units of Y. So that causes our budget line to pivot outwards because prices have fallen. Now this is important for us to remember because sometimes it comes up in the quizzes. So that if the budget line pivots outwards, it means what has happened? The price PX, the price of good X has, the price of good X has fallen, right? If, however, it went from this way inward, if it pivoted inward, it means that the price of good X would have risen. So that would have meant that the price went from $1 to $2 for 1 unit of X. So the pivoting, the direction of the pivot is opposite to the movement in price. So if it pivots inwards, it means prices have risen. But if it pivots outwards, it means prices have fallen. You're following that? Now you can pivot on either side. You can pivot on the y-axis and on the x-axis. But for convenience, we're going to stay with the x-axis for now. All right? You're following this discussion here. Notice what happens. The area of what I can afford has become larger. You seeing that there now? So before it was it was the region 0 AB, and now, well, we should probably give this point a new point here. Let's call that C here. The new point now, the new area is gone from O or region OAC. So it's a larger triangle. This larger area here now. All of this is going to be available for us for all right, this area, this larger area here is available for us now. So our budget area has increased. So when prices fall, it increases my area of that I can afford. But what the more important thing that we want to do is that we notice that the budget line pivoted, changing the slope of the budget line. And what we're trying to illustrate here is that the budget line, the slope of the budget line represents the ratio of prices of one good to the other, good X to good Y. All right, so far so good. Let's look at this one here. When income increases to $40, so we're taking prices back to, right, so we're using the same price now of $1 for each item. So with an increase in budget income to $40, the budget line shifted outwards to the right. The individual can now afford more both goods. Note that the attainable area has increased on the diagram. So if now our budget is now $40, price of good X and price of good Y is $1 each, as we had before. You notice that the budget line has shifted from 30 to, well, actually, no, they took back, this is 15 here. So we're back at the situation where we are, at $2. So the price of good, right? So the price of good X is equal to 2, and the price of good Y is equal to 1. So we're back to our original budget line of 30.15. But if prices go up, our income goes up to $40, then we'll be able to buy 40 units of good Y, right? And 20 units of good X. That's this point here. So you notice that the budget lines are parallel to each other, meaning that the slope didn't change. Therefore, and the reason for that is because the ratio of prices didn't change. Notice that the budget line has shifted in a parallel manner, but the slope remains the same, indicating that the ratio of prices has not changed. If income decreases, the budget line would shift inwards to the left. the individual could now afford less. So when incomes rise, and this makes sense across the board, when incomes rise, we could afford to buy more of everything. But when incomes fall, we have to buy less of everything. So the movement outwards of our budget line is represented by an increase in income. But if we go backwards, then that represents where our income has fallen. So far, so good. Everybody's understanding that. Yes?
Yes, sir.
Okay, so all right. So we're at the point where we've understood about the budget lines and such, yes? Okay. All right. Okay, so things are going to get a little tricky from here on. So what I want to do, guys, is I want to give you all I'm going to pause the recording, and I'm going to ask you all to take a stretch or walk around, and then we'll come back, because this is it gets a little more tricky now. All right. So I'm going to stop the recording.